Good morning, good afternoon, or good evening. It is wonderful to have each and every one of you here. This is Mr. P signing on. Today we're going to be looking at our guided notes for section 11.3, volumes of prisms and cylinders. So let's go through some vocabulary. A face is a polygon that represents one side of a polyhedron. That is, any of these two-dimensional figures that form a part of the outside of your polyhedron. An edge is a line segment formed by the intersection of two faces. That is, something like this. The vertex is a point where those edges meet, so any of the corners, really, of this thing. The part that if somebody threw a polyhedron at you, you would least like it to hit. Speaking of, a polyhedron is a solid that is bounded by polygons only. So you see this has a rectangle, a rectangle, a rectangle, a rectangle back here, and a trapezoid up front, and a trapezoid down back. All polygons. A prism is a three-dimensional figure with two congruent parallel faces that are called bases. So this is an example of a prism because it is two trapezoids. Yeah, two trapezoids in the front and back bounded by a bunch of parallel faces. Like in this case, those are rectangles. But it could also be parallelograms. More on that later. Let's see here. Okay, a cylinder is a three-dimensional figure with parallel bases that are circled. That is, it's not a polyhedron and it's not a prism, but you could almost imagine it as if it were a circular prism. That's kind of the way that I explain it to my students. A cone is a three-dimensional figure that is a circular base and a vertex that is not on the same plane as the base. The height of the cone is perpendicular distance between the vertex and the base. That is, it has a base, a circular base, and some distance to this vertex up here. A pyramid is a three-dimensional figure with a polygon as its base and triangles as its lateral faces. The triangles meet at a common vertex right there. A sphere is the set of all points in space that are the same distance from a center point. So all of the points on the outside of this sphere are r away, the radius away. Just like a circle, but three-dimensional. A volume is the amount of space inside of a three-dimensional object or its capacity. A measurement of volume offers insight into how much liquid or how many physical objects a person can fit into an object. In similar solids, two solids of the same type with equal ratios of corresponding linear measures, such as heights or radii. The ratio of corresponding linear measures of two similar solids is called the scale factor. The two similar solids have a scale factor of k. The ratio of their volumes is equal to k to the third. Perhaps more on that later. Here's some formulas. The volume of a prism is the area of the base times the height, where b is the area of the base and h is the height. Now, normally on a right prism, the height is just that measure there, but on something called an oblique prism, the height wouldn't be that part in blue that I'm highlighting. The height would actually be this distance in pink. Like how far you would fall if you fell off the top. Think about that. The height of a prism is how far you would fall if you fell off the top. Same goes for cylinders, except what you're more interested in, since the base is now a circle, its area is pi r squared, and the height hasn't changed its meaning. Still, if you were standing on top, that's how far you'd fall. That is the height. Tell whether each is a polyhedron. If it is, name the polyhedron. So a polyhedron means that it has all polygon faces, and this is absolutely true. This here has 1, 2, 3, 4, 5, 6 rectangles as its faces, and so this is a rectangular prism. Oh, I forgot to say yes. Okay, and this one here, it is because it's got triangles on all three lateral faces and then a triangular base. They meet at a common vertex up here, so this is a polyhedron, and it is a triangular pyramid. As for this one, it's not a polyhedron because its faces, its bases specifically, are not polygons. Its bases are circles. So no, because it's a cylinder. Since it's a cylinder, it is not a polyhedron. For what it's worth, its lateral face is in fact a polygon. Its lateral face is a rectangle, oddly enough. Okay, volume of a prism. Find the volume of each prism. Again, the volume of any prism is the base, the area of the base times the height. We use a capital B because it's the area of the base. And this is a triangular prism, which means that its bases are these triangles. So we find the area of those triangles, which is 1/2 times, well, times the base. Let's make it so that it's actually a, and by with the little b, the base of the triangle times the height, 1.5 centimeters. So I do 0.5 times 3 times 1.5, which is 2.25. 2.25 centimeters squared is the area of this triangle. We're going to multiply that by the height. Why? Because I want you to imagine that each of, like, this triangle here has 2.25 squares on it. If you were to divvy it up to 3 equal parts that way, and I guess 1.5 equal parts that way, that this thing would ultimately have 2.25 squares on it. And now, if we imagined making that three-dimensional, each of those little layers would have 2.25 cubes in it. And since it goes 5 back, there would be 5 layers of that. So we're going to do 2.25 centimeters squared times 5 centimeters, and that's going to be 11.25 centimeters cubed. Yay! Now, how about this one? So this one's actually nice. They've given you the area of this base, even though we can find the area of a hexagon. It's just time consuming, so that was very nice of them. So since the volume equals the area of the base times the height, the volume of this is going to be 10 inches squared times the height, which again is the distance you would fall if you fell off the top of the figure, which means the volume is 40 inches cubed. How do you like that? Looking at those two, I never would have guessed that one would take less time, but it did. Yay! So now let's find the volume of a cylinder. So remember, the volume of a cylinder is the same as the volume of a prism, where the volume is equal to the area of the base times the height. It's just in this case, the base being a circle means that the area of the base is pi times radius squared. The height's the height. So let's find the volume, the area of the base. So it's 2.5 centimeters in radius. So the area of the base is equal to pi times 2.5 squared. And we're going to do this exactly first, which is 6.25 pi inches squared. So now we're going to take that base area, 6.25 pi inches squared, and multiply that by the height, which is 7 inches. Now, when we're doing this, really you're going to multiply the non-pi parts. So 6.25 times 7 is 43.75. So that means that the volume is equal to 43.75 pi inches cubed. Which, depending on what we're talking about, that might not be very helpful. So if you actually do 43.75 times pi, I get 137.445, about 137.445 inches cubed. Now, you might be getting something a little different from that because you're using 3.14 or 22/7, or I had a student last year tell me for the first time that there's another fraction for pi that almost represents pi that's pretty good, but I forget what it is. Okay, let's find the area of the base. That's pi times radius squared. Since the diameter is 12, the radius is 6, which means that the base area is 36 pi centimeters squared. Now remember, the height is how far you'd fall if you fell at the top here, so the volume is 36 pi centimeters squared times 11.8 centimeters. So if you do 36 times 11.8, I get 424.8. So the volume is equal to 424.8 pi centimeters cubed. To approximate that, we do 424.8 times pi, or 3.14, whatever it is you want. I get 1,334.549 centimeters cubed.